In this video, we will see resource allocation graph to detect deadlocks. As bankers algorithm using some kind of table like allocation, request, available, all that thing to understand what is the state of the system. Similarly, if you want to understand the state of the system, instead of using those table, still you could even represent the same information in the graph. That graph is called resource allocation graph. A graph consists of vertices and edges. First, we will discuss vertices. We have two types of vertices, resource vertex and process vertex. Process vertex is represented as a circle. For each process, we have a circle node. And resource vertex, we have two types, single instance and multiple instance. Resources are represented as a rectangle, and single instance means there may be an empty rectangle or with a single dot. Here, this dot represents one CPU is available. And in multi-instance, the number of instance of available resource of that type. We have, for example, we have 3 registers available of the same type. So 3 dots are here. So these 3 dots represents 3 registers are available. Now coming to the edges of resource allocation graph. There are two types of edges in resource allocation graph, assign edge and request edge. If you already assign a resource to a process, then it is called assign edge. Request edge, it means in future the process might want some resource to complete the execution. That is called request edge. So if your process is using a resource, an arrow is drawn from the resource node to the process node. That is assign edge. If an arrow drawn from the resource to the process, then it is assign. If a process is requesting a resource, an arrow is drawn from the process node to the resource node, then it is a request edge. For example, we have single instance resource allocation graph. If there is a cycle in the resource allocation graph and each resource in the cycle provides only one instance, then the process will be in deadlock. Here I already mentioned a rectangle, yes, empty rectangle meaning it's a single instance. We may put a circle here, but but an empty rectangle represents a single instance. For example, if process P1 hold R1 and process 2 holds resource R2 and process 2 holds resource R2 and process 1 is waiting for resource 2 and process 2 is waiting for resource 1. Then here the process 1 and process 2 will be in a deadlock. Here process 1 is waiting for a resource held by process 2 and process 2 is waiting for a resource that is held by process 1. So both processes are waiting for each other to complete. So this is a deadlock. Next one, we have another example that shows process 1 here, process 1 and process 2 acquiring resources R1 and R2. R1 is held by process 1, R2 is held by process 2. And here, while process 3 is waiting to acquire both the resources. Here in this example, there is no deadlock because there is no circular dependency. You can see there is no circular dependency. Here, for example, resource 1 is held by P1, resource 2 is held by process 2, and process 3 waiting for R1 and R2. Here, process 1 does not need any other resources, hold only R1. If process 1 completes its execution, R1 will be released and it will be allocated to process 3. Process 2 is holding only resource 2 and it does not need any other resource. So, if process 2 completes its execution, resource 2 will be available and it will be allocated to process 3. So, cycle in single instance resource type is the sufficient condition for a deadlock. And for example, here multi-instance of resource allocation graph with multiple instances. Here, every cycle in a multi-instance resource type graph is not a deadlock. If there has to be a deadlock, there has to be a cycle. So In case of resource allocation graph with multi-instance resource type, the cycle is a necessary condition for a deadlock but not sufficient for a deadlock. Here we have a multiple instance of resource R2 here. So R1 is held by process 1 and R2 here R2 is held by process 2 and also R2 another instance of R2 is held by process 3. Here there is a cycle but R2 here this resource instance is held by process 3 and you can see process 3 don't need any other resource. So if process 3 completes its execution, one instance of resource type R2 will be available that will be given to process 1 that will break the cycle. So the cycle is a necessary condition for a deadlock but not sufficient in case of multi instances resource allocation graph.